Hello, everyone. It's my pleasure to present our project to you guys. I'm Stella, the leader of first group, the NOBUG team. The data set for our study is Queensland traffic accident data from 2001 and to 2021. Firstly, I would like to introduce the three main speakers, Stella, April, and Bill. There are three main parts to the project agenda here. First is data exploration analysis, modeling and forecast, insight analysis. And now we invite Apple to introduce her part.
Okay, hello everyone, I'm Apple. So our report will contain these three parts. Our team got a very big data set about Queensland traffic. It's not from customers who came to us waiting to find solutions, and it's not from coworkers who need us to monitor data performance regularly. Everyone in our team was thinking if there is any insight that matters to all of us. So this data has 6 tables. The major one, road crash locations, we simply call it table 1, where locations and the characteristics of crashes within Queensland. It contains all reported road traffic crashes from January 1st, 2001 to June 30, 2021. And other 5 tables provide different statistical dimensions with same time range. The only thing they have in common is crash year, a time variable. So this is a good starting point. Next page. We count the total number of crashes per year. 2021 has half-year data. That's why the value is just half of 2020, as shown in the red line. And we also know Queensland government stopped capturing property damage only for crash severity since 2011. This can explain the sharp decrease appears between 2010 and 2011. So after filtering them out in the green line, we can see 2020 is the lowest, 12,098. We also noticed that in Queensland, a road traffic crash which results in fatality and all person hospitalized is a serious crashes. So we counted serious and non-serious crashes by year. Next page. Yeah, in 2020, the difference between them is just 222. Then we convert to the serious ratio. It becomes a record high. 49%. Stella? Are you sure? Yes. It becomes, 49, you can see here, right? So these findings of 2020 are very counterintuitive. We all know what happened in this year. COVID appeared in Australia. The first case was diagnosed on January the 25th. Queensland began lockdown in April. Then we plot the monthly trend. Stella? Yes, in April 2020, these 2 indicators goes in the opposite directions. And after April, the serious ratio still kept in a very high level. So what should the data be like if there is no COVID? And let's invite Stella to talk about our models.
Thank you. I will introduce to the modeling process. In order to get a data curve that is not affected by COVID, our idea is to use historical data to build a model and then use 19 years of data to verify the error and accuracy of the model. Finally, use the model to predict the situation beyond 2020 so we can see the number of crashes without COVID. According to our idea, we first divided the dataset into 3 parts according to the timeline. And the division was based on the time point when the first COVID case appeared. During the data exploration, we found that the data before 2011 was abnormal as a whole because the crash classification no longer reported property damage only. After 2010. Therefore, for the consistency of traffic data record, the relevant data before 2011 was removed. At the same time, we divided the remaining 4 categories into series and not series. Next, we have to diagnose the overall situation of the series. First, we decompose the data, and obviously we can see that the series has a seasonal component because the data produce a repeated pattern of 12-month frequency. In this case, the XiaoreJRMel model is more suitable for modeling because it adds a seasonal component to the XiaoreJRMel model. It better captures long-term patterns. The condition of time series modeling is that the series must be stationary. So we use ADF tests to test whether the series is stationary or not. If the series is not stationary, the difference, we can take a difference so we can obtain a stationary series. We can see that the original series is not stationary, but after the first difference, the series is stationary. So we can use it to the model. There are 7 parameters of XiaoreJRMel model. So we adopted a grid search approach to find them all. From our analysis just now, we can confirm 3 parameters, where the difference is 1 and the seasonality is 12. We can confirm the remaining 4 parameters by finding the model with the smallest AIC and BIC by grid research method. After computer calculation, we got the optimal model, XiaoreJRMel model here. And it has the lowest AIC, BIC is around minus 640. And its coefficient t-test also significant. However, for a good model, its residual should conform to the model assumption of normality, correlation, and randomness. Our model is really great, passing all tests at 95% significance level. At the same time, the model error and prediction error are very low, which means that the model can more accurately predict the data we need. Then let's take a look at the model fitting. There are 2 lowest values in the historical data. The first appeared between 2010 and 2011, when Queensland experienced once in 15 years flood. And the second was in 2020, when the government implemented a travel ban in order to control COVID spread. If we zoom in on the gray area, we can see a graph of the number of crashes predicted by a model without the impact of the epidemic. Here comes the point. We can see that the blue line, has dropped sharply after 2020, which is due to the traffic restriction in February and everyone home isolation, which caused the number of crashes to drop significantly to 641 after the restrictions were lifted in April. The number of crashes rebounded sharply to the level predicted, and the number was slightly more than previously predicted, reaching a maximum of 1,181. This may be due to the revenge travel psychology of residents, resulting in an increase in the number of traffic. Similarly, we feed the XiaoreJRMel model to the ratio of accident severity and predicted. Surprisingly, flooding did not affect the ratio of accident severity, but after travel bans were lifted in 2020, accident severity rose significantly from forecast. Let's zoom in. We see that after 2020 years, the February, the severity ratio dropped sharply to 0.4, rebounds to 0.53 after restrictions are lifted, and then repeats itself around 0.5, which is much higher than the model predicted. So why did the number of accidents increase and the severity of accident increase after travel restriction was lifted? So next, April will give up an insight analyst. April.
Okay, me again. Next page, please. Yeah. So now we all know if there is no COVID, this trend will be relatively stable. And let's have a look at two lowest crashes number in history. In January 2011, flights hit Queensland. The crashes number is the second lowest, but the serious ratio of the month meets our expectation. It changed with the channel crashes number and lower than the January's. So what's the difference?
Sorry to interrupt, Apple. I think I cannot see your presenting. I'm just checking to see if you can present or share your screen. Can anyone else see the screen except me? Or
I can see. Yeah, you can see. You can read.
Cool. Or otherwise, you can still talk through it while Stella is helping. Yeah.
Oh yeah. Sorry, because I moved.
Oh,
Sorry.
No problem.
Okay?
Yeah. I can see
Yeah.
It's figured out. Yeah.
Sorry.
Okay. So where I can start? Yeah. So in the first graph, January 2011, flights hit Queensland. So the crashes number in the second is the second lowest, but the serious ratio of the month meets our expectation. It changed with the trend of crashes number and lower than other Januaries. So what's the difference between these external factors and why there are 5 supplementary tables provided in different dimensions? That's a hint. Let's think about, how COVID affect road crashes. Does it affect weather or road condition or traffic sign? We all know the answer. COVID has a huge effect on people, both health conditions and our way of life. So we extract data from table A to table E, calculate the average level between 2020 and compare it with 2020. Here we list items with notable changes. For drivers, drinking and overspeed increase. Fatigue and using defective vehicles decrease. After t-test, the first 3 items show a significant difference. Then we use the same method for other items. Next page. We can see younger drivers and elder drivers both have significant difference in 2020. What about casualties? Next page, Stella. Serious ratio of drivers has a significant increase in the same year. And next. 17 to 24 group and the 30s group display an abnormal growth in 2020. Remember the predicted line? If there is no COVID, the serious ratio should not that high. So let's focus on behavior indicator with significant increase. Next page. The three points are drinking driving, overspeed driving, and more younger drivers aged between 16 and 24. So let's imagine if we could replay 2020, what we can do to reduce serious crashes ratio. We have 3 advice. Next page. The first one, take measures to lower alcohol intake. And the second one, on social media, enhance driver safety awareness, target 16 to 24 group. And the last one, apply more temporary speed cameras and increasing speeding fines. Okay, my part is done. Bill will talk about the limitations and next steps.
Oh, sorry, Apple, you should move. Your character. Yeah. Thank you.
Can you guys hear me? Cool. Okay, so about my part. First of all, I created a feed-forward neural network model, which also aims to predict the time series data of the monthly crush. And the ultimate goal was the same as Stella's, and to make just to make a comparison between the two models. And eventually, my RMSE is 75, which is much higher than the XiaoreJRMel model. And so, just so we know that the XiaoreJRMel model is our best final prediction models. And after concluding our predictions about the time series data, I felt that there should be. Hold on. Can you move on to the, never mind. So after concluding our predictions about the time series data, I felt that there should be other features in the data which could help us predict the casualties in the future. This could provide significant values to the authorities such as roadside assistance for them to be better prepared to deal with the potential casualties. And the feature I selected are road surface conditions, road speed limit, and road lighting condition. I chose these features because they are environmental factors which has high coefficient with the casualties. And as a result of the model, it turns out that the 70-kilometer speed limit road, wet, sealed road, and the dawn dusk conditions are the three most significant features which affects the casualties. And this will be very valuable for the government officials or the relevant authorities to rely on when they to better prepare for the accidents. And about our limitations and the future steps, first of all, the insights is that the data captured at different levels of the granularity limits the information feeding into the model. And for the modeling, our model choices are limited to the XiaoreJRMel model and FNN and the logistic regression model, and which provides fewer comparisons. And for the forecast, the rolling forecast was not included, and the forecast was based on the historical in-sample data points only. So in the future, I think we should introduce more analytical tools for the model comparisons, and also to gather more sufficient data sets for our prediction model training. And that'll be the end of our presentation. Thank you.
Cool, thanks very much for Team NOBUG. I think from your analysis, what we can get, the insight we can get is that the lockdown not only saved our lives from the COVID, but also the car crashes. So I'm just trying to open the floor to see if anyone have any question for the team. I think you can either come near me or type your questions in the chat box. Or maybe you can come up to the stage. Anyone? I can see someone's moving. Yeah, we got a question. Could you please quickly explain, Jay actually asked, could you please quickly explain the difference between the XiaoreJRMel and the XiaoreJRMel model?
Because the XiaoreJRMel model only fitted the normal series with trend only, but the XiaoreJRMel model can fit with the series with trend and also the seasonality. And after we composition the data, we can see we have a 12-month seasonality. So it's more reasonable to use XiaoreJRMel model. Yeah, it can capture the long-term pattern.
Cool.
Okay.
Chris,
yeah, so sorry to interrupt. Actually, I have a general question for you guys. So could you do a brief introduction how your model work? Is there any basic methodology to support your model? And could you also explain why you choose this model? So maybe I can see there are a lot of different AI models. So could you give me a reason why you want to choose this model into your project?
Beg your pardon. So you mean why we choose XiaoreJRMel model as the prediction model?
Yes, thank you.
I think it's a very similar question like previous question. So it's mainly because we want to use the time series to fit the model and use the crash count series only. So we want to fit a REMA model at the first time, but we found that a REMA model get a huge error when we fit it. So we changed to XiaoreJRMel model because at the first time we didn't decompose the data, so we didn't find the seasonality. So after we find the seasonality, so we use XiaoreJRMel model. So this is the best model to capture the seasonality. Yeah.
Yes, cool, good presentation. And I also found you guys offer me some like background information. So like which kind of effects is mixed by the COVID or something. Yeah, I think that will be a really insight for me. Yeah, thanks for your group.
Thank you.